Hello friends, a very good morning to all the students. Am I audible to all the students? Okay, fine. So friends, you remember that in the last lecture we have started one of the important chapter, the third unit of the subject of basic mechanical engineering. The chapter name is the properties of the gases. So friends, let me ask you some of the questions related to our last lecture or the points which we have covered in the last lecture. So friends, can anybody can give me the answer? In Boyle's law, which parameter is kept constant? In Boyle's law, which parameter is kept constant? Okay, I am getting the responses from the students. Very good. All the students has given me the right answer, perfect answer. So in the Boyle's law, the temperature is remaining constant. Very good. The next question from my side. Anybody can give me the equation for the combined gas law? Any student can give me the equation for the combined gas law? Okay, in this I am getting some of the mixed responses. Okay, so some of the students are only the concept is clear. So combined gas law, dear students, remember that is PV upon T, that is equal to constant. So that is the equation for the combined gas law. Some of the students has given me the answer PV is equal to mRT. That is the equation of the state for the perfect gas. We have developed different equations and all the equations are having their specified names. The final question from my side, can any student give me the name of R0? Give me the name of R0. Okay, very good. So in this question, there is no confusion. Okay, molar gas constant, that is the wrong answer. Characteristic gas constant is again the wrong answer. So I am getting majoritively the correct answers, that is the universal gas constant. Okay friends, so remember these all points which we have discussed in the last lecture. So let us proceed further in the current session and in the chapter of the properties of gases. So these are the contents which I am going to cover in this session. First we will understand the concepts related to the specific heat of the gas. Though we have already covered this concept in the first chapter of the introduction, again we will revise those points related to the specific heat. Then we are going to make the derivation of the relation between Cp and Cv. Moving further, we will understand the concepts about the internal energy and the enthalpy of the gas. And finally, we are going to understand some of the basic concepts related to the different gas processes. So the first point of this session, that is the specific heat of the gas. So friends, in simple terms, the specific heat of a substance may be defined as the amount of heat required to raise the temperature of unit mass of the substance through 1 degree. We have already studied this point in chapter number 1. I hope you remember this definition. Also, we have understood and remembered that for solids and liquids, we have only one value of the specific heat, whereas the gases, they have the two values of the specific heat depending upon the manner in which the gases are heated. So there are two processes can be followed for the heating of the gases. The first one that can be either at the constant volume conditions or the gas can be heated at constant pressure conditions. So the first specific heat for the gas is known as the specific heat at constant volume, denoted as CV. Definition is same as that of the specific heat of the substance. Only one change we need to remember, that is at constant volume. So specific heat at constant volume CV is defined as the quantity of heat required to raise the temperature of unit mass of the gas through 1 degree, but the condition is at constant volume. Hence we are telling it the specific heat at constant volume. Similarly, we can define the specific heat at constant pressure. It is denoted as Cp. So specific heat at constant pressure is the quantity of heat required to raise the temperature of unit mass of the gas through 1 degree at constant pressure conditions. So friends, I hope you have understood both these points, that is the concepts of Cp and Cv. Let me ask you a good technical question. Can I have the specific heat of the gas at constant temperature? Can I have the specific heat of the gas at constant temperature? Yes or no? Okay, majority of the students are giving me the answer, that is no, sir. Okay, so no is the right answer, because if we consider the specific heat at the constant temperature, then we are going to violate the definition of the specific heat. Because in the definition only we are telling that it is the amount of heat required to raise the temperature by 1 degree for the unit mass of the substance. So whenever we are having the constant temperature, there is no heat interaction and we cannot raise the temperature of that body. Okay, so try to understand this point. So let us proceed further in the next topic, that is the relation between Cp and Cv. Dear friends, try to note down this point. This is one of the most important questions from this chapter. I am repeating the statement. Dear friends, this is one of the most important questions which is asked in your theoretical examinations from this chapter. So try to note down the points which we are discussing and try to note down the steps of the derivation, so that the derivation becomes perfectly clear in your minds, and if asked in the examination you can score full marks out of this question. So before starting the derivation, first we need to mention the notations which we are going to use in the derivation. So firstly, we are assuming T1 and T2 are the initial and the final temperatures of the gas respectively in Kelvin. Remember friends, in my previous lecture also I told you that 1 I will be considering as the initial state, the starting point. 2 I will be considering as the final state, the end point. So T1 and T2 are the initial and final temperatures of the gas. We are taking it in Kelvin. Capital V1, capital V2 are the initial and final volumes of the gas respectively in meter cube. P is the pressure of the gas in kilopascal. M we are considering the mass of the gas in kg. Cp and Cv we have already understood and we have remembered. They are the specific heats of the gas respectively at constant pressure conditions and constant volume conditions, and we are taking the units, that is kilojoule per kg Kelvin. And capital R, we are knowing that it is the characteristic gas constant, and we are taking the unit of the R, that is again in kilojoule per kg Kelvin. So these are the important 6 notations we are going to use continuously during the derivation of Cp and Cv. So I hope you have noted down all these points. Now friends, let us consider mkg, mass of the gas heated at constant volume conditions. And because the gas is heated at constant volume condition, the temperature of the gas is increased from T1 to T2. There is the increase in the temperature. So the amount of heat supplied to the gas at constant volume conditions can be written as QV is equal to mCV T2 minus T1. Dear friends, remember that we are taking the subscript, that is V, because we are telling that the heat is supplied at constant volume conditions. So this is the simple equation that we have derived from our standard equation of Q is equal to mc delta T, where C stands for the specific heat, delta T, that is the difference in the temperature. So repeating that point once again, thus the amount of heat supplied at constant volume conditions is given as QV is equal to mCV T2 minus T1. Proceeding further, now when the heat is supplied at constant volume conditions, no external work is done. We are going to understand this point in detail in the next lecture whenever we are going to discuss the constant volume process. So at that point, this particular concept will be perfectly clear. So right now you just remember, when the heat is supplied at constant volume conditions, no external work is done. That means W is equal to 0. And all the heat energy which is supplied to the gas is utilized for changing the internal energy of the gas, because in the first chapter we have understood first law of thermodynamics, and the equation of the first law, that is Q is equal to delta U plus W. In this equation, if I put W is equal to 0, then I can tell that Q is equal to delta U, where delta U, that is nothing but the change in the internal energy. So substituting this term in equation number 1, we are getting the answer, that is the change in internal energy. Delta U is equal to QV, that is equal to mCV T2 minus T1. So friends, always remember that we cannot find the absolute value of the internal energy. Hence, always for calculating the properties of the gases, we are always finding the change in the internal energy. And this delta U can also be justified by observing the equation. In the equation also, we are taking the change of the temperature. That is the final temperature minus the initial temperature. So friends, I hope up till now you have understood the derivation perfectly. I want the responses in the chat box. Up till now the derivation is perfectly clear in your minds. And you have also noted down the equations. Okay, thank you all for the positive response. Next friend, now moving further, now we are taking the another process. Now let us consider mkg mass of the gas heated at constant pressure conditions. And again, the temperature of the gas is increased from T1 to T2 because we are having only two temperatures, the initial temperature and the final temperature. So again, in the same manner, we are going to write down the amount of heat supplied at constant pressure, that is QP is equal to mCp T2 minus T1, the same equation, the same format which we have used in the first case of constant volume. Only the change in the subscript, we have taken the term that is P, because now we are considering the constant pressure process. Now friends, remember this important statement because majority of the students are not writing this statement during the examination. When the gas is heated at constant pressure conditions, the heat which is supplied to the gas is utilized for two purposes. When the gas is heated at constant pressure conditions, the heat which is entering into the gas is utilized in two purposes. The first one, that is increasing the internal energy of the gas, and second one is for overcoming the external resistance, or in simple terms we can tell that for performing the work. Try to focus on this point because I have observed that majority of the students are not mentioning this statement during the derivation, and this is one of the important statement for the further derivation. So repeating this statement once again, when the gas is heated at constant pressure conditions, the heat supplied to the gas is utilized in two purposes. The first purpose is to increase the internal energy of the gas, and second one is for overcoming the external resistance or for doing the work by the gas. So we can write down, thus the increase in the internal energy can be written as delta U is equal to mCV T2 minus T1. We have already derived this equation previously. So we are using the same equation for the internal energy because we are using the same gas, the same boundary conditions, only the method of heating is changed. So delta U, that is QV, is equal to mCV T2 minus T1, and we can write down the work done or the energy spent in overcoming the external resistance, that is P V2 minus V1. So we are going to derive this equation for the work done in the next lecture whenever we are discussing the different processes. Just remember that is W is equal to P V2 minus V1. So considering this point, now I can write down according to the first law of thermodynamics or according to my previous statement, the amount of heat supplied is utilized in two purposes: for changing the internal energy, for doing the work done. So I can write down QP is equal to delta U plus W. We are having all the terms, so substituting the values of all the terms. So QP is equal to mCp T2 minus T1, delta U is equal to mCv T2 minus T1, and W is equal to P V2 minus V1. That is equation number 4. I hope you are getting the points and you are also noting down the equations. All the students have understood up till this equation number 4. I want the responses in the chat box. Are you getting the points up till equation number 4? Okay, fine. Thank you all. Majority of the students are giving me the good positive responses. Okay, so that is the good appreciation I am getting from the students. Thank you very much. So now let us proceed further in the derivation. So now we are going to take the characteristic gas equation. We are going to apply the characteristic gas equation to mkg mass of the gas at the beginning and at the end of the constant pressure heating process. So friends, if we are applying the characteristic gas equation for mkg mass, we can write down PV is equal to mRT. So at the initial state, since it is the constant pressure heating, so I am not mentioning PV. So I am just writing PV1 is equal to mRT1 at initial state 1. And similarly, I can write down the same equation at the final state 2. That is PV2 is equal to mRT2, where m is the mass of the gas, R is the characteristic gas constant. Using both these equations, now I can write down P V2 minus V1 that is equal to MR T2 minus T1. So substituting this value of P V2 minus V1 again in equation number 4, we can get this type of the equation, that is MCP T2 minus T1 is equal to MCV T2 minus T1 plus MR T2 minus T1. So now you are observing that in this particular equation, the m is constant. So m is cancelled out throughout. Also the bracket, that is T2 minus T1, that is also common. So it is also cancelled out from both the sides. So the remaining terms, and again rearranging the terms. So after removing the common terms from both the sides and rearranging the terms, now we have reached to our final answer of the derivation, that is Cp minus Cv, that is equal to capital R. I hope you have studied this equation and also you have used this equation for some mathematical calculations at your school level. And this equation is known as the Mayer's equation. So in examination, if you are asked to derive the Mayer's equation, then you have to make this derivation, that is Cp minus Cv is equal to capital R, where Cp is the specific heat at constant pressure, Cv is the specific heat at constant volume, and capital R, that is the characteristic gas constant. So dear friends, I hope the derivation is now perfectly clear in your minds, and also you have noted down these steps one by one in your notebook also, so that you are well aware with the method of the derivation and how we are reaching towards the final answer, that is Cp minus Cv is equal to R. Getting the positive responses from the students that they have perfectly understood this derivation. So dear friends, again I am repeating the point. This is one of the most important question which is generally asked in the theoretical examination. So if this question is again asked in your exam, then I suggest that you just attempt this particular question, write down the derivation perfectly, following all these steps in a good sequence, making a good presentation, and you can score the perfect full marks of the answer. Let us now proceed further with the next topic, that is the internal energy of the gas. The internal energy, in simple terms, it is denoted as capital U, and it is considered as the total energy content in the gas. So if we are considering the total energy content of the gas, then we can tell that the internal energy is the sum of the kinetic energy, the potential energy, the chemical energy, electrical energy, and all other forms of the energy that are possessed by the atoms and the molecules of the gas. Dear friends, if you remember the equation for the internal energy which we have derived in the last derivation, the internal energy depends only on the temperature for an ideal gas. And friends, mathematically the change in the internal energy is given as delta U is equal to mCV T2 minus T1. Note down this point perfectly in your book by big handwriting, good handwriting. Remember that point, that throughout the chapter of properties of the gases, whenever we are asked to find out the change in internal energy, there is only one equation to find out the change in internal energy. And the equation is delta U is equal to mCV T2 minus T1. So this is only the one standard equation we are going to use throughout this chapter for calculating the change in internal energy. Let us now proceed further with the next term, that is the enthalpy of the gas. So friends, for the sake of the simplicity and for the convenience, we are taking the summation, that is U plus PV is defined as the enthalpy H. So let me ask you a simple question. This concept we have also studied in our first chapter of introduction. So enthalpy is a form of energy which is the summation of the two energies. The U stands for the internal energy. What does the PV represents? What is the energy which is represented by PV? What is the energy which is represented by PV? Try to understand my question. Okay, roll number 44, Vidhi has given me the perfect answer of the different answers I am getting. So the perfect answer which I was expecting, the PV that represents the flow energy. Okay, so it is the summation of the internal energy and the flow energy. Majority of the students are giving me the answer, that is work done. It is also a type of energy, but according to the definition of the enthalpy, we are not considering PV as the work. So try to understand this technical terminologies, try to understand the definition. So thus mathematically we can write down total enthalpy, that is H is equal to U plus PV. If we are considering the unit mass, that is m is equal to 1 kg, we are considering the specific properties, and specific properties are denoted by the small alphabets. So I can write down H is equal to U plus P into V. Dear friends, see in both these equations, H I have changed, U I have changed, V has been changed, but P has not been changed, because P, pressure, is an extensive property. If I am dividing by the mass, there is no effect on the pressure. Okay, so P is an intensive property, it does not depend on the mass. Whereas the enthalpy, internal energy, volume, all are the extensive properties, they all depend on the mass. So for the extensive properties, we can always have its specific value. So enthalpy is also known as the heat content of the gas. It is a thermodynamic property, and the change in enthalpy, that is delta H is equal to mCp T2 minus T1. So we are going to derive this equation for delta H in the next topics which we are going to discuss. So these are the basic concepts about the internal energy and the enthalpy. So now let us proceed further to the different processes, that is the gas processes. So the work interaction taking place in the system can be classified as the flow work and the non-flow work based on the nature of the process. So we are having two processes to be studied, that is the flow process and the non-flow process. The flow process is a type of process in which the fluid enters the system and leaves the system after the work interaction. But remember this point, the flow process is such a process which occurs in the systems having the open boundary. We have already studied the open thermodynamic system which is having the mass interaction as well as the energy interaction. So for the open systems, the flow process is possible, but contradict to that, opposite to that, in the non-flow process, it is a type of process in which the fluid enters the system and leaves the system after the work interaction, but the non-flow process occurs in the system having the closed boundary. That means the non-flow process is possible for the closed isolated system. The flow process is possible for the open thermodynamic system. So remember these shortcuts, remember these important points. Flow process is possible in open thermodynamic system. Non-flow process is possible in closed thermodynamic system. And friends, according to your syllabus, we are going to study the different non-flow processes. We are going to study 5 non-flow processes. They are the constant volume process, the constant pressure process, the constant temperature process, fourth one that is the adiabatic process, and the fifth one that is the polytropic process. So friends, with this I am concluding this session from my side. Thank you for watching today's session. Have a nice day. So before proceeding to the doubt solving session, I hope you have already received the questions of the assignment number 1 of the subject of basic mechanical engineering. We have given only 4 questions to write down. All the 4 questions are most important from the exam point of view. So friends, whenever you are noting down the assignments, try to refer the standard textbook which we have suggested to you, that is of the Books India publication, and try to present your answers in a good manner. Try to present your answers in some pictorial representations. Do not write down the answers in the paragraphs. Make the appropriate points, use the bullet points, try to give appropriate space, write in the good handwriting, because your overall presentation will be getting you good marks in the assignment. So let me discuss the answers of the different questions which we have given you in the assignments. So the first question, that is classify the thermodynamic system. Give 2 engineering examples of each of the systems. So we have already understood there are 3 types of the thermodynamic systems. So the basis of classification of the thermodynamic system, that is according to the mass interaction and the energy interaction. And according to this criteria, we have divided the thermodynamic systems into 3 types: the open system, closed system, and the isolated system. And also we have understood the different engineering examples. The second question, that is again the important question, the zeroth law and the first law of thermodynamics. I hope you remember that point of the zeroth law, that is in context of the thermal equilibrium. And the first law, that is nothing but the law of the conservation of energy. So try to present your answers in a very good manner. The third question, that is the definition of the heat. Define the heat in the particular terminologies. Then we need to compare the heat and work. In my discussion, I have explained you the similarities and the dissimilarities between the heat and the work. Also, the same thing is given in your textbook. And finally, you have to note down the sign convections. In my lectures, I have given a good pictorial representation of the sign convection. The heat energy entering the system, that is taken positive. Similarly, the heat energy leaving the thermodynamic system, that is taken negative. and opposite to that is considered for the work interaction. So you have to draw such type of the figures and make a good presentation. And the last answer, that is define the prime mover, classify the prime movers. One of the most important question, give the definition of the prime mover. The prime movers are classified on the type of the energy used by the prime mover. Basically, they are classified into two types, the thermal prime movers and the non-thermal prime movers. Thermal prime movers are further classified into 5 different types. Again, the fuels are classified into 2 types. Very good description is given in your textbook. The non-thermal prime movers are classified into 3 types, that is according to the water energy, the tidal energy and the wind energy. I hope you remember all those points. So friends, this is the way you need to write down the assignments, okay, and submit as per the instructions which were already discussed. So now friends, the session is open for your questions. I have already received some of the questions in the chat box. So let me first answer, sir. There are 4 questions in only. Need to write in assignment 1. Yes, rule number 66 for BME assignment number 1. There are only 4 questions and you need to write down the answers of only 4 questions which we have mentioned. So make a good presentation. First write down the question, then answer in particular point-wise format. Another, sir, in comparison, do we have to write the similarities also? Yes, rule number 49. Both the points we have to cover in comparison, that is the points of the similarities and the dissimilarities. And finally, we have to make the sign conventions, that is the positive and the negative. I hope I have answered the question which have been raised by rule number 66 and 49. I want the responses. Okay. Any other question any student want to ask of the current session, of the topics which we have discussed in today's session? Dear friends, let me inform you once again, the relationship between CP and CV is one of the most important question which is generally asked in your theoretical examination. So perfectly prepare that particular derivation. Any other question if any student want to ask? Sir, do we have to write about specific heat? No, there is no need to write about the specific heat because the question is totally specifying, define the heat, make the comparison between heat and work. So understand the question and write the answers to that particular point. If you are asked to write down about the specific heat, then only you need to write down the answer of the specific heat. Okay, I hope I have answered your question. Rule number 23. Dear students, try to understand the question and then you need to note down the answer. While writing the answers, if you are having any problem, then you can drop me a message in the WhatsApp or you can call me. No issue for that. Okay friends, I hope you are not having any doubts in the current session. So I am concluding the session from my side. Thank you again. See you in the next lecture.